Okay, welcome to Learning Synthesis with Pure Data, Series 2, Lesson 5. I'm starting here at my website, lwmmusic.com. As if you were following the series thus far, we are focusing on LWM Rack, which has undergone a change. Here, let the picture stay up. There we go. LWM Rack now is more like a Eurorack modular system, and I've just released the basic set with just a few modules in it, and I'll be adding modules as we go. The LWM Rack page at my website is under Software and LWM Rack, and to see how the system works, you do want to actually see this video first. It's on the YouTube channel under the Pure Data Patches playlist, but you can also go here to the page and find it. Depending on when you're seeing this video, if there's other releases, this first video will be further down on the page. Here's the actual video. But its number, LWM Rack 1.00B beta. The basic set will stay the same. You want to see this video first before working with LWM Rack, even if you are familiar with Pure Data. If you're not familiar with Pure Data at all, then you want to start with my learning series. It's this series, but the first series in the series. It's under the learning page, yes. Learning Synthesis with Pure Data. Learning Synthesis with Pure Data Series 1 is where you want to start. Oh, excuse me, that's the wrong one. Yes, here it is. Learning Synthesis with Pure Data Series 1. Episode 1, Lesson 1. That's where you want to start. I just have to say that because I don't know who's seeing the video and if they just found it from a search or something. But in any case, let's get on about what this video is about. As releases come out, I'll release a video with them showing the modules and how they work. So you want to see this one first, the basic set, and then as I add modules, the videos will be about that module and how it integrates with the rest. And then if you want to see how they're built, that's in the series you're watching now, Learning Synthesis with Pure Data. Throughout Series 2, I've been building LWM Rack, and now that it's undergone this change that I've released as 1.00, this one, Lesson 5, is where that begins. So now that I've confused you thoroughly, let's get on with the episode. So I'm going to put this down, and what we're going to do is look at this here. This is the download. There's two downloads with each release. One is a blank set, well, basically all the modules and no example, and then there'll be one with an example patch built, and it's basically one that I use in the videos. So if you've seen that video already, and if you haven't, I'm asking you to do so. So see that video on LWM Rack 1.00 beta, the basic set, so you see how this works. And then basically what we're going to do in this video is see how these modules were built, in case you want to get in there and change some things around and so forth. So anyway, as you know, this is the rack file, rack.pd, that I just opened. And within it, if we right click on this and go to open, this is the modules.pd file. This is where you place your modules and you save this. And then when you want to use the thing that you build, you use it from here, the rack.pd file, because it hides all the patch cables, makes it all nice and neat. So anyway, let's open this up though so we can see these modules. Now each module is loaded from file, and it's all in the modules folder. I minimized the folder, so let me bring that up. So the rack file's here, the modules file is here. That's this, what we're seeing right now. and it loads these abstractions into it from the modules in the tools folder. The tools are the more nondescript things that perform, conversions in a lot of cases, and the modules are the larger ones here. And so these get loaded in. Hold on a second here. Modules. These get loaded in and they save parameters into these folders with a text file that matches the name that you give it when you create it, as you've seen in the video that comes with the release. And so the name also gets displayed here, so you know if you have multiple modules of the same type, which one goes with which. Like in this one, for example, since there are, I believe, 2 oscillators, aren't there? No, I do not have. Yes, I do have 2 oscillators. Look at that here, OSC-A and OSC-B. So if I go into the folder that goes with the oscillators, that's the VCO, Voltage Controlled Oscillator folder, you see there's 2 text files there that are saving the parameters, one for each of these modules. So you can go about your business of setting parameters in them, putting modules in. You just save this file. These parameters get saved automatically. And so it's easy for you to build and know that your stuff's being saved as you go. You just do need to save this file, though, after you place in modules and patch them up. So anyway, let's look at the modules now. I'm going to right-click on the MIDI in module and go to Open. And let's zoom in a bit here. Okay, so the first thing is, you see the red outline here. That is basically when you right-click on the canvas background, go to Properties. You can say Graph on Parent when you check this off. And then I always check off here to hide the object name. Otherwise it would display VCO tilde right up here, and I don't want that. And then you set its size here. It's 75 pixels by 300. So you see this is 75 pixels wide, 300 tall. And those are the main things I use. The margin here just says the red rectangle that creates is 100 pixels from the top and 100 pixels from the side. And then it's 75 wide and 300 pixels tall. Basically in LWM Rack, let me close this temporarily, I'm going to be building modules with those proportions in mind. Everything will be 300 pixels tall. Many modules will be 75 pixels wide. If I need to make them wider for more controls and stuff, then it'll be like 150, 225, 300 divisions of 75. So that way things are easy to calculate when you maybe need to resize your background. The background here is, let me get into edit mode, a canvas. And so when you click its upper left corner, you get this blue highlight. You can right click on that, go to Properties, and you see it has a certain size to it. I made it 618 wide. I don't know why not 620. But that's its width, and its height is 300. The height is 300 because that's the height of these modules. So that way they fit inside. If you want a little space to the top or bottom, you can do that. You can make the canvas a little bit taller, like 320, to have 10 pixels above and 10 pixels below each module. But then if you resize the canvas, you need to resize the red rectangle here that allows this to be displayed on the parent patch, which is the rack.pd file. Rack.pd simply just has, for example, modules.pd. You don't type the extension, just type modules. There we are. That's what it is. This is the modules file. And so this displays at 2 pixels wider and taller than the canvas. That way the canvas fits inside the red outline, which is 1 pixel in thickness. So that's why it is 620 width and 302 pixels tall. So if you wanted to resize this to have a border above and below, you can make it 320, and then here you would make it 322 tall, just so your canvas fits inside of the red rectangle, and so forth. And if you need to resize, like if you have more modules going across and you want to make it wider, you can. If you want to make it 2 rows, you can also do that. Since these are 300 pixels tall, you would want your canvas then to be at least 600 pixels tall to accept them on top of one another. If you want a little space in between them, you can also make it 620, for example, pixels tall, or 630, giving you 10 pixels of space here, here, and then below. And so you can resize this to make the GUI fit whatever you're doing. Let's go back to the MIDI module and see how it works, though. Basically, the MIDI module is designed to take MIDI information in, and that's done in this subpatch here. If you right-click on PD Inputs, you can open it up and see the MIDI input stuff coming in. We have here a receive. Anytime you see a receive, that means there's something else by this name that's sending information to it. This is receiving $0 channel send. And that's actually this box right here. If I right click on it and go to its properties, you'll see its send symbol is $0 channel send. So that means this is sending information under this symbol name, and then the receive over here receives it. So when you put in your MIDI channel here, this receives it because it uses it in this patch. And that way all my objects here, the graphic objects, the sliders and the number boxes, all have send and receive symbols that I have similar names for. $0 channel send, and its receive symbol is $0 channel recv. And then we have here note, that one's $0 note send, and $0 note recv, receive symbol. And so there's a scheme to the naming. And those of you who are not familiar with it, the whole $0 is such that if you have multiples of these modules in a patch, since there will be more of these, I don't want their send and receive symbols to be the same, because you want them to stay sending and receiving information within this module only. And the way you do that is use the $0 at the beginning of your names, because $0 is seen by PD, and when something's loaded from file, as this is loaded from the VCO, well, not the VCO, the MIDI in file here, this file is this. When it gets loaded in, all those $0 to PD become unique numbers. So that way all these sends and receives stay within the patch here, this subpatch, or abstraction as they call it when it's loaded from file. So this loaded from file is just sending and receiving with itself, so long as you use the identifier $0. And then -channel -send just says that it's the channel, and it's the send symbol for the channel. You gotta have different names for the send and receive symbols, otherwise they create a feedback loop, sending and receiving to themselves. So anyway, so channel does come in here, and this is how it's used. We have a note in object, and the note in object brings in any notes that are received via MIDI, and whatever MIDI port you set in, for example, the media menu, you go to MIDI settings and say that your MIDI in device is, my controller keyboard is the SL Mark II. And so when I play notes, they come in here. We'll see it displayed over here, and their velocities. So note in brings in note, velocity, and then what channel it came on. And this is where I use a select object, select, its creation argument is 1, but since it's hooked up here to the right inlet to a receive, anytime you change the MIDI channel, it receives it here, and the select object then judges its input on the left inlet versus what's been sent into the right inlet. If nothing's been sent in, it goes with the creation argument. And so what it's sensing, since this is set to channel 1, select object compares anything coming in to channel 1. So when note and velocity come in a message together, along with the channel number, the select object determines, is it on channel 1? And if yes, it bangs out the left outlet. If not, it sends whatever number it received out the right outlet. I convert that into a bang here by using a trigger. Abbreviated T space B means trigger a bang. So when the number comes out, it triggers a bang instead, and it bangs the message 0. Otherwise, it bangs the message 1 if it is the MIDI channel that you select. If it is, 1 goes to the spigots down here. Otherwise, 0 goes to them. Now what spigot does is it allows things to flow through if it's open, and what opens it is the message 1. What closes it is the message 0. So basically, if the note and velocity, since it comes in a message together, note, velocity, and channel, if it's on channel 1, the spigots are open and it lets the note and velocity through. If it's on channel 2, it closes. So for example here, if I change this to channel 2, or any of the other MIDI channels, up to 16, let's say I select MIDI channel 2. Well, my keyboard is still set to transmit on MIDI channel 1. So now I'm playing keys and nothing's changing. It's not receiving any of this because it's not on channel 1. I mean, it's not on channel 2, which I have selected here. Let's go back to channel 1. There we go. Note and velocity then pass through. So that is basically like a valve that says, is this on the channel you selected? If not, forget it. Why do I have this? Well, let's say you open up 2 different LWM racks at the same time, and each one has their own MIDI in. You could have one set to one channel, another set to another channel, and that way you can have them as 2 different instruments functioning simultaneously. The idea being that each one is set to different sounds and so forth, and that way you could have multiple sounds being played on different channels, and the appropriate notes and velocity will go to the appropriate channels, and therefore be received by the instruments and how they're set. And I have that same mechanism over here for these, which is pitch bend in, using the bend in object. The right outlet has channel. Left outlet is the number range of the pitch bend, 0 through 16,383. It's a high resolution controller in MIDI, 14-bit, so it has a wide range of numbers. But in any case here, it just checks if it's on the right channel. If it's on the right channel, it lets it pass through, and it gets sent out to $0-bend-in. This object here that displays pitch bend is not receiving it at this point. There's another subpatch that I'm going to show you where bend in is received. These 2 things, however, go straight to the boxes here because the receive symbols for these are note send and note receive, velocity send and velocity receive, and so this is going straight to these boxes here to be displayed. And in this case, the bend information and the mod wheel information are being sent to a subpatch that I'm going to show you next. This is once again the same thing, the select and messages of 1 and 0 going to spigot to make sure that the mod wheel and bend information are on channel 1. Control in 1 basically means the MIDI controller number 1 is what this receives. So it's not receiving anything other than mod wheel. because mod wheel is by the MIDI standard controller number 1. So next we go to conversion. This is the other subpatch I just mentioned. Here is where bend in gets received, and here's where mod in gets received. I did this patching for one basic reason. In LWM Rack, I like to convert the MIDI controllers, which in the case of mod wheels range of 0 to 127, and in the case of pitch bend 0 to 16,383, I like to convert them to ranges of 0 to 1 because it becomes more useful and more of a universal range of values that works well for patching. And so you can hook them up to various different things to have your controllers control any variety of things in LWM Rack that you want to connect things to. And so this is that conversion process here. I've looked at this and I realized I could have done this a little bit simpler, but basically what the idea is here it has two outlets coming from a Moses object. The Moses object is set to 8192, and what it does is it takes streams of numbers in, and if they are below this number in the creation argument, they go out the left outlet. If they're above it or equal to it, it goes out the right outlet. I'm doing this because I want to be able to create a center value, so that way when the pitch bend is centralized, its number is 8192. And since I'm going to be converting this to a range of 0 to 1, I do this to make sure 8192 is going to be 0.5, halfway between 0 and 1. And this is just to make sure of it, because since we're talking about a range of numbers that are 0 to 16,383, that really is 16,384 different numbers, because 0 is one of them. And so in an even set of numbers, there really is no middle. They divide by 2 evenly. There's no middle value with an equal number below and above it. So I have to kind of create one, and I notice that when my pitch bend wheel is stationary in the center, because it is spring loaded, in other words, it's set as if it's not being used, no bending, its value yields 8192. So that's really the center state. So what this does is if it's below 8192, it simply divides it by 16,383. Whenever you take a number range and divide it by its maximum number, you'll get, as a result, a range of 0 to 1 that is like a percentage. Just like test scores. If you have a test worth 50 points and you get a 45, you divide 45 by 50, you end up with 0.9 or 90% as your test score. It's the same type of thing here. We're just converting it to percentages, a range of 0 to 1. And so coming out the left side, trigger, float, bang, bang, what this does is the float means the number passes through this outlet here, and then 2 bangs get triggered, a bang here and a bang here. Basically, these bangs are set to open the spigot to let this number through and to close the other spigots so nothing else comes out of these. I just found that I needed to have that flow control when working with Moses. So when the stream of numbers is coming out this way, it closes these off, and it shoots it out here where it goes out the outlet, which is actually not an outlet. It's a send to $0-bend-receive. This guy here. So now this receives it because it's a range of 0 to 1 and 0.5 is in the middle. Now, if it's 8192 or above, it comes out this outlet, and then the select box determines, is it 8192? If it is, it triggers these bangs. These 2 bangs close the other spigots, opens this one, and this bangs through it 0.5. So that way a 0.5 comes through if it's 8192. And then if it's not, that means it's above 8,192, so it simply gets divided by 16,383, and we get our percentage again. In hindsight, I could have made this simpler without even Moses, and just have a select 8,192, and have it send out the 0.5, and I could still use a spigot, where it would send the 0.5 out and close the other one. But I only really need one other option. If it's not 8,192, whether it's above or below it, it doesn't matter. It still gets divided by 16,383, and that number can come out. So I could have simplified this, and in fact I probably will for the next release. That'll be one of the changes, is just to simplify it, and less functions for PD to perform, and so that way we'll have that. This is the same thing, except since we have a different range of 0 to 127, I have 63 as the center, and so it determines if it's centered at 63, send out the 0.5. Otherwise, divide by 127, and you get your percentage range of 0 to 1. This just makes sure there is a center ground, because in a lot of things you hook up, you do want to have some sort of center in your range of 0 to 1 that's like 0.5, especially like for panning. If you want to use this to control a pan or something, or say the pulse width on your pulse wave, you want to be able to find that 0.5 center. And so this allows there to be one, rather than it being like 0.482 or 0.516 or something like that, where it's just above 5 or just below 5 but not exactly 5. This allows you to get an exactly 5. Alright, so anyway, both of those send their results here, now in a range of 0 to 1. And then all these go out here. So all these number boxes, except channel doesn't need to go out, but the note, velocity, pitch bend, and mod wheel all come out here straight from these graphic objects, and so these just get sent out the outlets here. And then since the outlets won't display with like a background canvas, I made it like this, where they have like abbreviations for what the outlets are, and so that way on the outside, if you hover around here, that's your note out. If you hover around here, that's your velocity out. Hover around here, that's your pitch bend and your mod. Now they are color coded. Blue means it's within its natural MIDI range. Orange means it's within the range of 0 to 1. So pitch bend and mod wheel are in the 0 to 1 range, so they come out color coded as orange. And anything that's orange up here receives that number range. So that way it's easier for you to kind of select what things you want to patch things to. For example, you can have mod wheel control over here like your sustain level or attack time and things like that. You could have the mod wheel control your mix in the combiner to mix between two different signals and stuff. Anything orange, you can have it control. And so you select what things you want to have control what. Now these are just the basic MIDIans, and I've already made two other modules that contain other MIDI controllers. And those are coming out in release 1.01 beta, which should be out this week in a few days, because I already made them and I've kind of like went through a debugging process, and so they're ready for beta release, and so they'll be coming out soon. Another reason why I had to get this video done, because the next one's ready to go. So anyway, let's look at the VCO module. Now, I didn't cover in MIDI in something to the right, which is this, but I'll cover it now because the MIDI in is basically has the same type of apparatus here. This governs the saving and loading and initial parameters of your modules. Now, what's different in this module, we once again have subpatches that do all the work, basically, and calculations. But we also have inlets here because you see the VCO has inlets. Well, close this so it displays. It has inlets, whereas MIDI in does not. MIDI in just receives from MIDI. But VCO you can patch into. And so we have inlets at the top here where we're bringing in $0 $0 -note -in. So this is where note gets patched to, and it comes in here. I'll explain this clear and change objects in just a second. Let me just get through the rest of these inlets. Here's where pitch bend comes in. And then here's where you have an audio rate in, because there's a tilde next to the inlet. So audio signal comes in here where you can use an audio signal to control your pulse width. And you can use an audio signal to control FM. Okay, so I'll get to the pulse width and FM as we look into the internals here. But first, let me talk about the clear and the change objects here. What change does is change lets you send numbers through it, but it only lets the number go through if it's not the same as the last one it received. This is to block the same number from coming through multiple times. I found early on in building some of these synth modules, even before LWM Rack, that like when you play a note on the keyboard and play another one again, it kind of stutters your oscillator a bit if it gets the same frequency twice, and there's no reason for it to have it come in twice. So I block things from receiving repeated numbers because there's no reason to have that. I mean, if you play the same note twice, it's important for the velocity on and off to go to your ADSR module, but the oscillator doesn't need to change its frequency, so it stays where it's at. So anyway, this is bend in, and I also have a change on that just so it doesn't keep coming through. And what clear does is, since number boxes, as soon as the thing opens, always start off at 0, this clear is one of the first things that happens when the patch opens. Because here's the load bang that sets off all the things that should happen when it opens. And the first one is sending $0 -clear. And it sends a bang there. So a bang comes through, bangs the 0 through change. So that way the 0 goes through, and then change is now going to stop any zeros from coming through unless something else happened in the meantime. In other words, a repeated 0 you don't want, because it'll just be like zeroing things out to you. And when you have like inlets here receiving things from other modules, when these open, you don't want those zeros coming through again, and so forth. Or if your mod wheel's not being used right now, you don't want it sending zeros in and zeroing out parameters that you have it hooked up to. So that was just something I discovered that was happening that I eliminated by doing this. So that's the first thing that happens, is it clears the zeros through. And then the second bang goes to this subpatch, initial. And what initial does is it initializes things. If there's anything that I don't want it to be in its normal 0 state when it first opens, this sends like initial values to those things. For example, a 0.5 goes to bend in. So that way, the first time you put in your VCO, it'll automatically have the pitch bend at a state of 0.5, so that way it's an unbent state. Because the first time you put it in, you may not even have patched the pitch bend up to it yet or anything. And so you don't want to have to send pitch bend information to make sure that it's centered and not bending. This just initializes it in the state that it should normally be to start. And then we have zeros going to some things like the octave, semitone, and sense. These are what allow you to detune the oscillator and so forth from the MIDI note coming in. And so we want these to be 0 to start and stuff, like when you first put the module in. And so the rest of these, it's the same thing. It's basically setting things to what I believe should be the initial setting when you first make this module. Now that's just to cover the fact that, when you first make the module, it's good to have some initial settings set in motion so everything works to start and works the way you would want it to by default. If, like in this case, I open the rack and all these modules get loaded and they were used before and may have parameters that were saved, that happens next. So this is where that happens. This is a bang that happens next, and it happens at a 20 millisecond delay to make sure these things happened. And then what it does is it bangs symbol $1 into this subpatch. Symbol $1, this first of all is a symbol box, meaning you can have words, numbers, and stuff together. It's something that PD doesn't interpret. It just thinks of it as more like a name, but it calls it a symbol. And when you put a $1 next to symbol in making a symbol object, it will take whatever was the creation argument of the whole patch. And that's where, from the initial video when making these, I said, alright, you type in modules /VCO tilde so that you open the VCO module from the modules folder, space, and then a name. This name, because it's after that space, is really the creation argument. For example, if I wanted to put in another MIDI in module, modules /MIDI in space, and I could say in2, for example. In2 gets put here, and the reason why is because of this. We're going to go back to this module, because this symbol $1 says that thing that you typed afterwards, in this case it was in2, appears in the symbol box and then gets banged through and goes into this subpatch. And one of the subjects of the subpatch here, as it comes in through the inlet, it labels the $0 name, which is the receive of this canvas here that displays the name. So this is where the name gets displayed. This is a canvas, and its receive symbol is $0 name. So it says label $1, which means label it with the symbol. That becomes the label of the canvas, and so it displays it like that. And so that's how the name gets displayed. But this symbol also comes through to this trigger that has a bang and an anything. Anything here represents anything. So that's really where the symbol gets sent. So the word that you type, in this case, this was created with OSCA as its creation argument or its name. And so OSCA gets sent into here, and it says read VCO $1.text. And so the $1 variable gets replaced with OSCA, and that's where the text file gets read. So it looks to see if in the VCO folder is there an OSCA text file, and there is. Now, this is why errors appear when you make a module for the first time. It's because that file isn't there, and it says can't open. So that error appears when you make them for the first time. But it's okay, don't worry. It's a known thing that will happen, and it's supposed to happen. The text file hasn't been made yet. And the reason being is you've just made it for the first time. But in any case, let's say you're opening it after already having made something, and that file's made just like it is now. This reads the text file, and that gets sent to text file here. And then the next thing that occurs, well, there's a bang that bangs rewind, and then another bang here that just sends a bang into it. Because these are the commands. Like this says read this file. Rewind means go to the beginning of the file. For some reason you have to do this. It doesn't default go to the beginning of the file. And bang says read the line. So if you bang twice, you can read line by line if it's multi-line. My text files for saving parameters are just a single line in the text file. So there only needs to be one bang. It reads that first line, and that first line for this abstraction has 1, 2, 3, 4, 5, 6 different numbers that it saves as parameters that get saved with the file. And here's where they get sent out. And so here they're being sent out to the graphic objects that contain them. So that's where the parameters are being sent for the octave, the semitone, sense. Frequency doesn't get sent. That just gets calculated based on the note being played and these other factors that come into play in the middle. And then amount, pitch bend amount gets saved. MPWM, I believe it gets saved too. Or doesn't it? Yes, it does. So it gets saved too. And so this is where all those things get sent to the graphic objects, so your parameters are loaded. Now, once you've made it for the first time, though, after a second, it will write to file. Remember, I had the initial thing here to begin with, so when you make VCO for the first time, this initializes it with initial settings. So there are some settings. And then this thing that receives $0-save, this is a bang that gets sent into this receive here from outside, and actually it's right here. It's the last thing in the load bang set of things to do. Delayed 40 milliseconds, meaning 20 milliseconds after this happens. Turns on Metro that sends a bang every second to $0-save. So every second it's saving its parameters, whether you change them or not. It's just saving them. I'll explain why after I show you the mechanism. But anyway, $0.0.save, here it receives the bang and it triggers 3 other bangs to happen. And they of course proceed in the order of right to left. The first one says clear, which clears the text file object of information. And then the next one bangs in this packed message, which contains all these sent information. These are receiving from these guys here, your parameters. So it's receiving from them, so it's receiving the parameter values here. It gets packed up into a message, and then when you bang it, it sends it out through the set $1, $2. This is saying these are just variables in order. And the set message basically sets text file. It sets a line of the text file. It says this is what the text file should be. And so it should be basically these numbers here. Replace these variables, $1, 2, 3, 4, 5, 6. And so they get set in the text file. And then the last thing that gets banged here is to write the text file. And so you see it writes VCO / $1.text, and that $1 is replaced. It's a variable that receives the symbol name. And so that's where it gets written to the text file that has your name right here. So that's how the saving works. Now, why does it save every second? That's so you don't, otherwise I'd have to make like some sort of bang or something here and you'd click it to save. When you're editing and making an instrument here, you don't want to have to hit a save button for each one of these all the time. Like let's say you're playing around and you set some octave settings, some semitones, do some detuning, move a slider and stuff. Then you got to remember to save, save, save. This automatically does it for you. So as your parameters get filled in and you're doing stuff, it's saving them. And you don't have to worry about it. The only thing you have to worry about is saving your modules patch file here. Because as you patch things up, once you save this, it saves the modules you have and how they're connected. The module's parameters get saved through the save function that I just showed you here. So that's how that works. Now, we have here a subpatch, PD Nyquist. This basically helps us deal with aliasing issues. Aliasing is when some frequencies are being generated that are above half of your sampling rate. The Nyquist theorem is a theorem that states that in order for a digital sampling to be accurate, and that includes synthesis when you're not sampling, but generating, in order for it to be accurate, the highest frequency being used should be half of your sampling rate. Since the standard sampling rate, the CD standard 44,100 is like the minimum you should use for music. Half of that is 22,050. Basically, I have this calculate, alright, whatever your sampling rate is, cut it in half, and then take 20% of it. This number here that's left, it subtracts 20% from that half of your sampling rate. It's saying this is where we should start low passing. In other words, this is the cutoff for your low pass filter. You could think of it as a slope. It's passing everything up until a certain frequency point, and then it slopes off until it's cutting out completely. Sloping off to infinity, basically. And so you need to begin this slope below your Nyquist rate, or the highest frequency you want. That would really be 22,050, so this is well below it. Just from hearing and doing some things, I found this to be a good threshold, 20%. And so at that point it starts sloping off, and definitely it's cutting things out by the time you get to your Nyquist ceiling. And so where this comes into play is all these oscillators that come out. These subpatches contain the oscillators. And the first thing they go to is a low pass filter, which receives this calculation that I made in that subpatch, and that's set as their cutoff frequency, where they will begin cutting off higher frequencies. So that reduces aliasing. But I did notice in some of these, I was still hearing some tones, especially in the sawtooth, but also in the square and a little bit in the triangle, of some tones below the frequency when I started playing higher notes. And so this apparently wasn't taking care of all the aliasing. So I also made a high pass filter, since these oscillators are just generating a fundamental pitch plus the harmonics above it. Anything that's below the fundamental is just noise or aliased frequencies. So that's why I made a high pass filter, and I set its cutoff point freq.send. That's the frequency right here. So whatever is the fundamental, this gets calculated based on the note value coming in, any octave detuning you do, and semitones and cents, and any pitch bending. The result comes here as the actual frequency that is being generated. And that's what gets sent to the oscillators here. And then anything below that is being sloped off and eventually cut out here. So there might be a little bit of aliasing between the cutoff and where it completely cuts off, the slope that occurs. But after hearing this, I wasn't hearing those tones that were disturbing me before, and so I'm getting some pretty good signal out of these oscillators now. Pretty pure signals. So anyway, that's what those are for. And then each one of these is a subpatch for an oscillator. But before we get to that, I should mention this in the middle. Here we have a conversion subpatch. This is where it generates the frequency that the oscillators get. And as you see, it's a little bit involved. I'm just going to summarize, and then if you want to get into the specifics of it, this is the same mechanism I used in the synthesizer I built in Learning Synthesis with Pure Data Series 1. And I believe it's lessons 4 and 5. I can double check that. We'll double check that in a second. But in those lessons, I have in one of them the octave, semitone, and cents calculations, and then in the other I have pitch bending. And so you can see how this does what it does. But basically what happens is your note comes in. These are quite simple here. It's easy to transpose semitones and octaves in MIDI. Octaves, like if you want to go up one octave, you just take 1 times 12 and it gets added here. If you want to go down an octave, the way the number box is set, you can go down an octave with a -1, for example. So that way a -1 comes in times 12, and you add that to this, it ends up being subtraction. So that's how it changes octaves. And then for semitones, it's the same thing where it's plus or minus. I go up to 11 or down 11 in the allowable range, because if you want to go more than that, well, that's 12. That's like an octave plus however many semitones. And so that gets done here. It's the same thing. Easy stuff, since a MIDI note's coming in. So after that happens, then the harder stuff of pitch bend occurs, as well as sense, because sense divides any frequency up into 100 different slices between it and its next semitone up and next semitone below. That takes some calculation. So that's all this stuff here. But basically this does all the calculations. So what ends up down here is how much you are pitch bending the note, how much you are changing it with your sense, octave, and semitone detunings here, and the result gets sent here. And then obviously you see it gets sent out of there. It gets received in here by these guys, as well as here where we do the high passing that I talked about. But in these, this is where your oscillators are. And once again, in Learning Synthesis with Pure Data Series 1, I make a similar multi-oscillator module. And if you want to see how you generate the different wave shapes, you can see that video. And I'll point that out in a moment. And so basically here's where the frequency comes in. It gets packed with your glide time. There's a glide setting right here, which allows you to put time in milliseconds, minimum of 20. And that's how much time it takes to go from one note to another. So you can bend up like going ba, ba, from note to note as you play them. It's a common setting in monophonic keyboards, monophonic synthesis. So that way you can have a, kind of like a scooping in between the notes you play. And this is where that happens. It's a glide time that takes the, puts in the milliseconds amount along with your frequency that gets sent to line tilde here, so that when it gets eventually to the oscillator down here, its frequency values are being sent in a line segment. And so it's sending it in a line segment, going from one note to another, to another, to another, over the glide time you set. If you keep it low, like 20 milliseconds, it'll be barely perceptible. Or actually not perceptible. It'll sound like you're going from note to note instantaneously. But it has a 20 millisecond line in there that helps get rid of artifacts, the snapping sounds that you hear whenever an audio signal changes suddenly without any kind of ramping. Next, here's where a plus tilde is, and receive FM in. The FM in is up here as an audio signal. This is for when I've already made it. That'll be 1.02. I've already made things. I have 1.01 and 1.02 like about to be released. And so this is where that oscillator would hook in, and its signal comes in here, and this is where that oscillator will be modulating frequency. And so you have that. And then it's just a simple OSC tilde for a sine wave. And then the other ones have the appropriate settings for their wave shapes. And of course, in addition, this pulse wave or square wave here receives pulse width modulation, so you can make it an actual square wave with a setting of 50 here, which gets converted to 0.5 inside here, which is what you need in number ranges for it there. And then you have a square wave, and the rest you have different pulse widths. And so it's like you get that effect. And in the first video, I think I've shown that, the LWM Rack release video, so you should know about that. And obviously I have it, I think I said in that video, set to 1 up to 99 here, because a value of 0 or 100, which would be a 0 or 1 in here, you don't hear anything because your pulse width needs to have some value. It can't be zeroed out, and it can't be 1, meaning all the way the entire width of the cycle, because then there's no pulse anymore. So it keeps it within a range in which you would hear it, and then like 50 is the middle ground. The reason why it's in these increments is so you could click on this and change your pulse width. It highlights it red while I'm sliding through them, so that's why you don't see them. Let's hit enter. Oh, but do that, enter. Why does it go back to 1? No, it's highlighting it red, that's why we don't see it, but it is moving up, and then when I hit enter it goes back to 1. So I'm just gonna, oh, maybe it's because of it's hooked up out here. Yeah, I have the mod wheel hooked up to pulse width, so it's putting it back to 1 because that's what's being sent in. That's right. Okay, anyway, so that's how that works. So the other patches are similar things, where you have your inlets at the top, outlets at the bottom, and subpatches that contain all the mechanisms, and then the saving functions are at the side here. So they're all pretty much the same, and the labels and symbol names for each one are like fairly logical one to the other. So here's the inlets at the top, outlets at the bottom. Those things that have that are not audio rate signals do need to have the change object in a clear function that I described earlier for extra protection. And then this one has very simple patching, since this is just a combiner. This is just taking one signal and another signal, and the one signal gets whatever level you set here, and the other one gets the inverse, so that way they are always one's getting the opposite of the other, so that way you can pan more towards the one or more towards the other, and control how they're combined. This is a very simple patch, and it saves your mix level. Just kind of like the MIDI module, this module only has one thing to save, your mix level, and the MIDI module only saves channel, because the other things are things that you play kind of like live and just happen. And since it initializes with a centralized pitch bend, you don't need to save it. And if you're using it's not like you're going to use the pitch bend wheel, bend up, and then close your patch, wanting it to open the next time with the pitch bend up. So it doesn't save those parameters that you don't need to save. Let's see here. And so in these cases, when we open the save subpatch, there's only one thing to save and load. Incidentally, I noticed in my other ones, for example, we're going to look at ADSR because we haven't yet. This one has multiple parameters to save. And so in the subpatch here, these multi-parameters, I noticed that here, anytime the first parameter thing comes through, it's going to save automatically whenever this parameter changes. So otherwise it saves every second, but when this parameter comes through, it shoots everything through also. I haven't had any trouble with it doing it, but for the next release I already changed that. This goes into a float box that's hooked up to this, so all these parameters only get sent once a second. In the early LWM Rack, I had it doing this stuff where it would trigger to send anytime anything changed. And since a lot of your mod wheel and controller signals are constantly moving or moving frequently, when you move it up, it's like save, and it kind of like stuttered the audio signal. And so that's why I make it just only every second. And that has not caused any trouble, so I'm happy with that. But in any case, this is a known thing that is not what I intended to begin with, but hasn't caused any trouble. But either way, I fixed it anyway for the next release. But I'm just pointing it out here. I might actually just fix this up and make it that way for these downloads as well. I don't know. Since it hasn't been causing trouble, I don't know that I need to, but what the heck. So anyway, that's probably something I will change, though. Well, I already have for 1.01 beta. I don't know if I will for going back and changing the 1.0 beta ones. I mean, it wouldn't affect anything as far as your parameters being saved to file. You could still use anything that you saved by slipping in the new modules. They'll still load them fine. So anyway, this is the ADSR, and then once again, everything's the same except there's only one signal out. That's your enveloped, controlled audio signal that comes out there. And here it has conversions, namely the conversions here to make sure your controller ranges that are normally 0 to 1. The way this works is like attack is time. And when you have a 0 to 1 range coming in, it multiplies it by this index value here that allows you to make your envelope proportionately wider or longer in time or shorter in time. And it multiplies this index value by this. So let's say you have it set to the minimum, which I set as 2000. 0.01 coming in would be 20. Now, if it was allowed to go to 0, then you could have a possible 0 attack time, which would create an artifact or snapping sound. And so this conversions thing takes in your ADSR signals and converts them to different ranges. Actually, it doesn't here. For the sustain, it doesn't, because that's not time, that's level. And you can have a 0 level. You could just turn sustain off, and then you just have your attack and decay time. But for your attack, decay, and release times, it just makes sure that it doesn't go down to 0. Basically what happens is it has a Moses here, 0.1. Most things flow through here, but if it's an actual 0, it just adds 0.01 to it. And so that way it just keeps it from going all the way to 0. A 20 millisecond attack time will sound pretty much instantaneous anyway. But in the audio world, if it's actually instantaneous, over a 0 attack time, you'll hear a snap. Now, the actual functions here of the ADSR, I'm going to once again refer you to another video because I've already described this in detail in another video. This is the same ADSR setup as I have in the synthesizer I built in Learning Synthesis with Pure Data Series 1. So rather than going through all this in this video, which would make this already long video much longer, I'm just going to refer you. I might as well do that now, because it's also the same thing with the audio out. When you open this up, as long as you're at least a novice with Pure Data, now that I've explained the upper part and the saving functions and stuff like that, you know, here's where you go in any module for what it's actually performing. And then, you know, this simple stuff should make sense to you. So we could pretty much bring this video almost to a close, but I said I'd show you where you can find out about the ADSR and then VCO, pitch bending, and calculating cents and semitones. In case you haven't seen my Series 1, here's where you can go for that. I'm going to go to the YouTube channel here. Oh, well, on the website you can also go to it. But then I'll go to the YouTube channel too. Here, let's zoom out. I know this is probably pissing you off. I'm used to working with a magnifier all the time. Alright, let's see this here. We go to learning synthesis with pure data, series 1. Now, the overall synthesizer will look different, but those areas like how to do an ADSR and how to do pitch bending and all that are in here. Alright, in lesson 4 is when it starts with making a MIDI input module. You don't need that. But here we go, the carrier oscillator video. This carrier oscillator has some of, what I put in this synth, so that would help you a little bit with that. And then as it progresses forward, this video, making an ADSR envelope. So it'll show you. In this one, I actually go through and make an ADSR, and you'll be able to see how the different functions work to create that ADSR effect. And then here, smooth playing monophonic synthesizer, that goes through how to make the synthesizer a little bit more smooth playing if it's monophonic. And that is also a function I have in this synthesizer, but it's with a subpatch here. One of the tools subpatch, this monophonic subpatch here. So this video would talk about that function that this thing contains. That you send your note and velocity through to make it smooth playing monophonic. In other words, your your releases don't cut off the notes you're playing. And then let's see here, we have adding MIDI pitch bend. So this one, I actually go through all the calculations to pitch bend and so forth in it. And then we have chorusing, and in this one is where I talk about the detuning with sense. This is where I add the sense, semitones, and octave detuning in this video. So in these videos, since I show all those calculations and stuff, I'll just refer you to them for those calculations rather than me taking another hour to explain those to you. But you can also look at the patching and just kind of interpret it from there. I gave you a pretty good map, I think, of how these are constructed and the different things and how I use symbol names and so forth. And each of these modules has a similar construction one to another and a similar approach to naming things, like the controls here all have names, $0 dash, like for example attack, dash, send, and dash, RECV, receive, for its receive symbol. So since they all have these similarities, you could probably navigate through these modules pretty well. So when I release in a few days 1.01 beta, it's going to have 2 MIDI modules in it that are extensions. Basically one that carries volume, pan, sustain, and expression, and another one that carries 8 definable, where you, the user, defines the the controller numbers that you want to receive on, and it allows you to have 8 different controllers. And then if you use 2 of those, you could have 16 controller things coming in, so it's a very expandable system. Okay, so I think that should be good for this video. Basically, lesson 6 of this series, oh boy, will be the construction of these new modules as I release them. So these videos are going to get shorter now that I covered the basics here. Those 2 modules I'll show you, like their construction on the inside and so forth, as they come out. And so the videos will be shorter because each release will be the new things I add or any of the changes I make. But from now on, I'm happy with this flow of this system. It's working out great. There won't be any more drastic changes. I think, just be like little fixes here and there and so forth. Okay, so I'll be seeing you next time. Ciao for now.